Okay, let's get to solving this. So remember the sign convention, which is very important here. Okay, sigma positive, negative is tension, compression. And for tau, positive, negative is where positive is clockwise and negative is counterclockwise. Okay, with that, we can start drawing the Mohr circle. Okay, so this is how we'll go about doing this. First, draw. Let's see. So draw the sigma axis. Okay, assuming that tau is the vertical axis, let's try to plot these stresses. So we have 80 MPa. Now 80 MPa is negative. It is a compressive stress. So I need to put a negative 80 there. And let's just put minus 80 here. This is sigma x. And then sigma y is 50 MPa. So again on the plot, it will be 50 on the right side of sigma x. Now somewhere here is the origin 0, 0. So that's where I'll draw the vertical line. That's my tau. Okay, now I've got that. Now let's go and plot the 2 points corresponding to this orientation. So we have 80 MPa and 25 MPa. So the 25 MPa on face on this face is acting in the clockwise direction. Clockwise direction is positive. So what I need to do is I need to interpret this as minus 80 plus 25 MPa. So this point, so this is 25. Yeah.
I got the positive direction.
Sure. So this face has 80 MPa, which is negative, and then there's 25 MPa, but I need to figure out the sign. But this 25 MPa is acting, the direction is clockwise, this way. Clockwise is positive. So I need to draw on minus 80, which is this, I need to draw positive shear stress. Okay, we can do the same thing for any of the faces for sigma y. By the way, we could also do this for this sigma x. Same thing, it's going to be clockwise. Now for the sigma y face, 50 MPa. So 50 MPa, we need to draw the corresponding tau. Tau is 25 MPa, but we need to figure out the sign. But this direction, if you see here, is this way. That's basically counterclockwise. Counterclockwise is negative. And so for here, we'll have to put a negative 25. This will be the other point. Yeah, I didn't quite draw it right. Should pass through. I'm going to just fudge this because my scale is not quite right. Okay, so those are the 2 points of interest. And now what I need to do is, now if you literally had one of those pieces which draws a circle, what you'll do is you'll take this to be the radius and just curve it around, right? You will draw a circle. Because if you know the center, you know the radius, so you could draw a circle. Okay, so that point we've got to circle just from those 2 points.
Professor,
Yeah,
so is the circle touching 80 and 50, or is it like a little further from 80 or 50?
it's not passing through 50 and 80. So
It's not, right?
it's not, no. This is where 50 is.
Mhm.
This is where minus 80 is. And so it won't pass through either of those. Okay, so this part is complete. We have drawn the Mohr circle, that's all to it. Now let's compute the principal stresses and their directions. Now this is particularly easy now that we have the Mohr circle. The principal stresses are just these points, this point and this point. We just have to fill in what sigma A and sigma B is. That's all we need, right? So hold on, I did an error here. No, the error is this is not right. It can't be middle of right. This is minus 80. This is 50. So the midpoint is of the circle is not at 0. Where would it be? Slightly on the left, but do you know the exact coordinate? You can get it from that minus 80. So minus 80 plus 50 is minus 30 divided by 2. So it should be minus 15. So that's why my figure was not looking right. Hold on. This should be this. Minus 15 comma 0, right? So it's minus 80 plus 50 divided by 2, which is minus 15. So there is an error here. So it should look like this. And that point, this point is still 0, 0. It's just where the sigma and tau, where the origin is. Okay, but the center is this. So here the formula is minus 80 plus 50 divided by 2 comma 0. So that is minus 15 comma 0, and that's pretty much what I wrote here. Okay, so there's a lot of clutter. This is part 1. I'm just going to copy that figure again and then clear it up a little bit and then write more things on it. We need this. We don't need this. Okay, so this is part 2. The question 2, which asks us to compute sigma A and sigma B. Okay, so how do we compute that? Well, what we need is that we perhaps can get it if we know the radius of the circle. So we know that this is the center and this is the edge. So we could get this if you know the radius. So the radius is this point is minus 50, 50 comma minus 25. So the radius, I can use the Euclidean norm. So 50 minus 15. square plus minus 25 minus 0 square. So this minus 15 squared minus 25 minus 0 squared. That comes out to be uh, let's go back. It's minus 25 from this figure. This minus 25 shows up here in this coordinate. Is that clear? Yeah. So I got 69.6. So this radius is 69.6. So can you compute the maximum stress now, sigma A? It's just a matter of, well, we know this is 15, right? This is minus 15 comma 0. And this is 69.6. So sigma A has to be 69.6 minus 15. 54.6. Here I'm just doing it based on the lengths. So this is the center. The distance from the center to the edge is 69.6, and then 15 is the distance from center to point the origin. So subtracting the two, you get sigma A. Sigma B is going to be this point. So we know that the radius is again 69.6. My figure is not perfect, so it doesn't look like this 69.6 is the same as this one, at least. But then based on the circle radius, that should be 69.6. That's the radius, the distance from the center to the edge. And then we know that this distance is 15. So in order to compute sigma B, it's going to be 69.6, which is this distance. I need to add 15. 69.6 plus 15. So actually, this is on the negative side. So I need to be minus 69.6 minus 15, because it's on the left side of the sigma axis. So it's minus 84.6. Here's one more thing left. I need to compute the direction of the principal stress. Okay, the direction of the principal stress, let's refresh that. Let's go to, which figure is that? Here. Okay, so I'm interested in computing theta s. It's the direction between that point wherever that stress acts with the x-axis. It could either be, you could either compute it this way, or it's also this way, same thing. You could choose it based on anything you want. Absolutely no problem. So we could go back. So remember, it's the angle between the x-axis and then the diameter which we drew. So go back. It's the angle between the x-axis and the diagonal we drew. So it could be either this or it could be this. So I'm just redrawing it here so that there's less clutter. Okay, I kind of know this point. This point is known. It is minus 80 for the y-axis is 25. That's this point. In order to compute theta s, you can write tangent of tan theta s is, I need to compute this distance and this distance. This distance, the vertical distance is, well, it is 25. And then I need to compute this distance. It's basically what? It's this distance. Again, not from 0, but from this point. So it's 80. The coordinate of this point is 80. The coordinate of this point is 15. So it's minus, let me write it here. This point is minus 80 comma 0. This point, being the center of the circle, is minus 15 comma 0. So this distance is going to be minus 80 minus 15 is going to be 65. Okay, just the magnitude. So tan 2 theta s is the opposite side, 25, divided by the adjacent side, 65. So doing this math, you get theta s as, I think it's 10.5 degrees. I think this is called P because it's the maximum principal stress. I should change this abbreviation. It's P. It's P. And that's 10.5 degrees. And then this is the other answer. This is the answer to the principal stress. So this completes part 2, which is principal stresses and the direction of the principal stress. Okay, there's one more thing left. We need to compute the maximum shear stress and the direction of the maximum shear stress. Okay, let me use this figure again. I'm solving number 3. Okay, now I'm interested in these points. And the angle I'm interested in is the angle between this plane and that point. So it's going to be back. I seem to have wished this should be P. And that was the source of the confusion. Theta s. So theta s is the angle between that plane and the y-axis. In this case, it's not really the y-axis, but it's the point of the maximum stress. So if you go back, it's this plane, and then, oh my God, this doesn't look right. This should be, it's all because this point is so close. This is the highest point, not this one. Then this is not the highest point. This should be the highest point. This should be the highest point because it's always over the center of the circle. This is tau A, tau B, and then the angle is this with it is 2 theta s. You could also get it by taking the angle from, eliminate this. could also get it the other way, which is from here. Okay, so let's get tau A first. Okay, so tau A is always minus tau B. It's always on the other side. We just have to find the magnitude. Okay, the magnitude is simply the radius, right? From here, so center to, so the radius is 69.6, I think. That's 69.6 MPa. That was easy. And then the other thing is we need to compute this angle. Okay, to compute the angle, we could use trigonometry, but we could actually use the fact that we know what theta p is. Theta p is this angle, right? We know that theta p is 10.5 degrees. So this twice theta p is going to be twice of 10.5, which is 21. So we know this is 21 degrees. This is equal to 2 theta p, which is 21 degrees from 2. And we also know that this angle is 90 degrees. You can just see from the figure. So that angle, theta 2 theta s, has to be 90 plus 21 degrees. It's 111 degrees. And theta s is so that's 2 is 10. It's 55.5 degrees. Okay, so what I would recommend you doing is redo this problem using formulas. So the formulas are, you need to use 3, let me call that 3 star, let's say. And then there is 4, and then 4 star. So the question is redo 1, 2, 3 using formula, and I think there's a formula for R2, or the formula for R. There's a formula for R, let me call that 5. And then this is 6. Okay, so redo this whole problem using formulas. For this one, it will be 5 and 6. For this one, it will be 3 and 3 star. And for this one, it will be 4 and 4 star. So this is to give you this, how you get those equations using just these answers, just using the formulas. Okay, let me do one more problem. But as I said, you could also do it using the formula if you don't like the graphical method.